right, ladies and gentlemen, that stirring music tells us that it's showtime for our replay series from last year's 2022 UPRT Safety Summit. What we've been doing is replaying all of our speakers. If you haven't had a chance to see one of these, we've broken them out. And what that does is it gives us more time for what I think is the most entertaining part of these presentations, which is the questions and answers. So I'm going to bring our guest for today in here, Captain John Cox. Hi, John. How are you doing today?
Good morning, Randy. How you doing?
I'm doing very well. We were comparing notes before today's broadcast and realized that we've known each other and have been working on this subject for 13 years. Yeah. I told you, John, that I thought that yours was a very appropriate presentation to end our safety summit with last fall. And unfortunately, it's a very appropriate subject for us to readdress. So I don't want to get ahead of what you're going to be telling the people in your presentation. So we'll have you back in here in about 20 minutes after your presentation is over. I'd like to invite everybody as they're listening, if you have questions for John about some of the things that he might be saying or thoughts that they provoke, please write those down. And in the comments section, you can tell us where you're joining us from. We would love to hear, and we'll look forward to answering your questions. And so now I'm going to have my boss, Paul Ransbury, who did the introduction for John. We'll see you on the other end, John.
It is my great honor and privilege to introduce our final speaker for the event today, Captain John Cox with Safety Operating Systems, where he is President and CEO. The title of John's presentation is What the Industry is Doing About Loss of Control in Flight is Not Working. John has an MBA in Aviation Management from Daniel Webb College. He's a graduate of the U.S. Navy Postgraduate School Aviation Safety Command Program. He's an ISBAO auditor and an IOSA auditor. From a flying background standpoint, John is a highly experienced airline, corporate, and general aviation pilot with over 14,000 hours, 10,000 of which are in command of air carriers. He held positions as instructor, check pilot, and test pilot, and he's type rated on Airbus, Boeing, Fokker, and Citation fleet. John has an extensive safety and industry background. He is the former Executive Air Safety Chairman for the Airline Pilots Association, or ALPA. He's the recipient of the Sir James Martin Award, ALPA's Air Safety Award, and U.S. Airways Safety Achievement Award. He's also been an accident investigator working with the NTSB on numerous major airline accidents. John is also very active in the news, where he's been showcased on ABC, NBC, CBS, CNN, MSNBC, C-SPAN, Aviation Week, Time Magazine, and many more. He appears as an expert on the television programs Air Disasters and Why Planes Crash. He's a fellow at the Royal Aeronautical Society, and his most recent paper is relevant to today's topic: Airplane Upset Recovery Training, History, Core Concepts, and Mitigation. And you may see John appearing in USA Today, where he authors a column titled Ask the Captain. I personally know John for over 20 years. He's just a great guy, fantastic leader, and I consider him a mentor and a friend. With all that, John, over to you to wrap up today's event.
I appreciate the opportunity to be part of the 2022 summit. It's an important subject, loss of control, and having been in the safety business a pretty good while now, it's one that concerns me primarily because we've not made the progress on yet as we have in other areas of accident prevention. So I'd like to talk a little bit about where we are and then open the discussion on where we need to go. From the beginning, loss of control in flight. I'm going to run some statistics for you just to give you an idea of the seriousness of this particular type of accident. About 46% of fatalities in airliner type accidents, these are Boeing numbers, are loss of control in flight. It's almost half. We find that this has stayed pretty much flat over the last number of years. Control flight into terrain was a major accident type with fatalities. Technology was able to pretty well reduce that significantly. But as we go forward and we have the discussion about what's the priority in reducing numbers of fatalities, we've got to put loss of control in flight first. If you look at some of the Flight Safety Foundation numbers for 2021, loss of control accidents are 10% of the accident types. But as you see, they're the deadliest. They have the greatest number of fatalities. So we don't see this type of accident all that frequently, but when we do, the results are typically a worst case scenario. ICAO, if we turn to them and you look at the overview of accidents that they did, and I pulled out 3 charts here from their ICAO safety report of 2022. You can see 2 losses of loss of control in flights and 72 fatalities. And it stands alone as far as severity goes. You can see here the total accidents by occurrence category and loss of control in flight. You can see, so there's 2 of them, but the total number of fatalities here, 72, and the next highest being controlled flight into terrain at 32. But the total number of accidents was the same. So the number of controlled flight into terrain accidents has gone down, and the severity has also diminished somewhat. Looking at a little bit further into the ICAO data, you can see that about 30% of the fatalities are controlled flight into terrain. We're almost 70% in this data set, and about 50% of the accidents. But about 70%, that's almost 3/4. So 2/3 to 3/4 of the total number of fatalities in this data set were loss of control in flight. NBAA, looking at the business aircraft. Over the last 10 years, 40% of the general aviation, commercial aviation fatal accidents have occurred because pilots lost control of the airplane. And that's an unacceptable high number to me. I think we can do better than that. More importantly, I think we have to do better than that. I think the expectation of safety of our passengers and the regulators, the media, the politicians, all those that oversee our industry, I think they have that expectation as well. National Transportation Safety Board. Since 2008, almost 3,000 people have died in fixed-wing general aviation accidents, and about half of those involve loss of control. That's a lot. That's a lot. And this is as far back as 2015, when Member Weiner made these comments. They have frequently had loss of control in flight on their most wanted list. We see continual efforts, but I'm going to submit to you that those efforts have not been as satisfactory as we had hoped. And I would also submit to you, we need to be thinking about how to get better results for the aviators that come through our training programs, that sit in our airplanes on a day in, day out basis. If you pull up something even as like Wikipedia, here are 18 events of airliner accidents caused by stalls. About half of the loss of control accidents are stall related. We have an awful lot of protection built into the airplanes to prevent stalls, yet we see this accident type continue. A number of the airlines are utilizing enhanced simulators with enhanced envelopes to show post G-brake aerodynamic characteristics, and that's a step in the right direction, because for many, many, many years, the idea that we would only fly it up to the approach to stall, the activation of the stall warning system, and correct any flight path deviation, then it's just not the real world, because in some cases we're going to see airplanes that are beyond critical angle of attack that are in fact stalled. And with high performance airplanes, and I've stalled some pretty high performance airplanes in my career, that point at which flow separation occurs in the G brake can be very pronounced, very aggressive, and require very well planned and executed stall recovery techniques. And it needs to happen quickly, because things can get out of hand very quickly, and then we end up with another loss of control event. Probably two of the better known ones recently. One happened, and the investigation is not finalized, but one happened outside of Gillespie Field near San Diego just after last Christmas. A Lear 35A on a circling approach, and it appears that this is a loss of control event from the flight path. Why? Lightly loaded. The weather was not good, but why? What happened here? What led this crew to make to let the airplane get in the condition it did? One that's a little bit better known and has been in the AOPA training cycle along with a number of others is another Lear 35A that was on circling the land at Teterboro. A lot of factors come into play here: late turns, experience of the first officer, but they let the airplane get slow, and this is according to NTSB, which I agree with in this case. They let the airplane get slow, and when it stalled, recovery was not possible due to their proximity to the ground. So these are two highly visible accidents that really give us a indication that we have not solved this loss of control event yet. We have not yet found all of the techniques, all of the training, all of the technology that can lower this sort of accident. And I submit to you, we should. This should be the priority. This needs to be the priority. When you look at, this is just in 2020, starting in 2020 and going through 2022, you can see there's a large number of these. They're all loss of control events. It's too many. And I think we can do better. There's 28 loss of control in-flight accidents in 31 months. If you put that on average, we're accepting a loss of control accident every 34 days. And I submit to you, we can do better than that. That is an unacceptable number in my view. I think the professionals that we have can mentor the ladies and gentlemen that are entering our industry and reduce those numbers significantly. The target that I would set, I think we can cut them in half. And I think we can do it in probably 3 years, 3 to 4 years. There's a massive pilot hiring that's underway around the world right now. That says that these pilots that are new hires are going to go through new hire training. They're going to go through initial training. And in that initial training, we can set the groundwork to improve their skill set to where we do not have a loss of control accident every 34 days. I think we can run it out to 60 days very quickly, 90 days in pretty short order. But it takes a commitment from all of us. It can't be just those of us in the safety world. It's got to include the training, the management, the pilots themselves, and a request, demand for training in upset recovery and prevention. One of the things that I hear from time to time is we should be focused only on prevention. Certainly prevention is essential, but history shows us that some crews are going to end up in position where we need there will need the recovery skills. And we as an industry, I think, owe it to those crew members to ensure that they have those skills. The IATA global database shows that over the last 10 years, 2009 through 2018, this is the most current I could find, 64 loss of control accidents were identified over a 10-year period. 94% involve fatalities to passengers and or crew. Loss of control results in more fatalities than any other accident category. Roughly 2,500 out of about 4,000. That number is too high. It also has one of the lowest survivability rates. So no matter what data set you use, be it for general aviation, business aviation, airline, commercial aviation, all the data shows us the same thing. It's showing us that we have too many loss of control accidents resulting in too many fatalities. That, ladies and gentlemen, in my view, says that it should be our leading priority going forward. The loss of control, things we can do, increase awareness to precursors. Obviously, if we can intervene earlier. Taking definite action, and from experience, I'll tell you that action may need to be aggressive, and in the event of a high altitude stall, it may require some patience to build enough energy into the airplane to be able to return to level flight. But it's increased awareness of the flight crews. That needs to be a remedial part of every recurrent. Enhance in monitoring of the airplane flight path. And flight path management, certainly automation can play a piece in it, but the monitoring of the flight path is a pilot function. And to know what areas where the vulnerabilities exist for the highest likelihood of an upset. These are all things that we can do. And mode awareness. Since we have had the automated airplanes, mode awareness has been a real challenge, and that continues today. But the emphasis on watching the flight mode enunciator and ensuring that the crews understand the mode and the implications of that mode throughout the flight. Loss of control accidents are almost always catastrophic. 94% of the accidents analyzed involve fatalities. This is too much. This is too much. If you look, and this is recent data, if you look at the IATA data from 2022, you can see loss of control in flight. That's the number of fatalities. That number we can and should reduce by no less than half. And then at a point later downstream, we'll make half of that. But we can do this. But it takes all of us in the industry. And I think it's time. Loss of control accidents, they have been trending down somewhat. It looks like right now we're going to have a good year in 2022. I say that with fingers crossed. But we had a very good year in 2015. The following year, we did not have a good year. So as we slowly improve this, we need to be careful that we don't consider one good year, such as 2015 or even potentially 2022, as a definition of success. Only after we have gotten the fatality rate down significantly over a period of time can we say that our mitigations are in fact working. How many people know this document, the Upset Recovery Training Aid, Revision 2? A lot of people worked on this, and I submit to you that this document, although written for large airplanes, has a lot of information for high performance, smaller aircraft as well. If you don't know this document, I would encourage it. For those of you in training, I would encourage that you use this good document and share it with your crews. It's got a lot of good information in it. A lot of people put a lot of time in it. And I think that it can be a good source of information. So I come back to my question. Is a loss of control accident every 34 days acceptable? Certainly technology has a place in this. It can help us reduce control. It helped us reduce control flight into terrain. It can help us as well. But is there better technology available? Are we recruiting those that create these sorts of technology and then utilizing them to our best advantage? Same is true of training. Training has made us better, but it needs to make us even more so. We need to train more pilots in upset prevention and recovery. We can increase focus across the industry. If we can increase the focus on the leading cause of fatalities, we can, in fact, improve aviation safety. And that's the goal for all of us. If you take one thing away today, I hope it is this. If we do nothing, we'll have the same results. Or if you do what you've always done, you'll get what you've always got. Henry Ford said that, and it is totally applicable to us today. If we do nothing, or we do the same things we're doing now, we will not have the effect that we need. Can we reduce loss of control in flight? Yeah. History says we can if we choose to. And I hope, in fact, that we do. I'd like to thank you for the opportunity to be a part and close out the Safety Summit. Hopefully, there's some things in there that will garner discussion. I'm certainly available if any of you would like to have further discussion on it. But it takes all of us. It's not just those of us in aviation safety. It takes the trainers. It takes the management. It takes the pilots. It takes every one of us to lower the single leading cause of fatalities. And thank you very much.
Well, John, that was as on spot here listening to it today as it was when you delivered it for us last fall. But as we've discussed, things haven't gotten a lot better in that time. For our listeners, I would like to encourage you. You have this opportunity to have one of the world's aviation safety experts give John your questions. We've got a couple already in queue. John, we'll take a look at those if we can. Let me see if I can post this up here for everybody to see. From Eric, he says, for brand new pilots beginning their training, what would you recommend that flight schools do to set the stage for their future dealing with loss of control events? I'll let you go, and I might have some follow-up thoughts, John.
I think that we include unexpected and training-induced or trainer-induced upset conditions on a regular basis, that you teach certainly the recovery from stalls, which is a routine part of training. But in addition, that the recognition of an upset condition and the same procedures used to drive the airplane back to the heart of the envelope. And you can start with the trainer, and it's applicable all the way up to an airliner. So if that is an integral part of your training, the likelihood of, if an upset does occur to you, you're going to revert back, primacy of learning, you're going to revert back to that recovery technique is increased. And that would be something as we train the next generation of aviators, and the pipelines are full right now. So we have a golden opportunity to implement that sort of training into literally thousands of incoming aviators. I think that will help in the long term lower the accident rate.
You know, John, at the airlines now, there is a requirement for upset prevention and recovery training. It's one of the results of the work that you and I and others did as part of the Royal Aeronautical Society. And it is interesting now that we have this demand for airline pilots that we aren't introducing those skills early on. We have a comment from Paul Strike in Australia talking about the fact that they're trying to include that at the ab initio level. And fortunately for myself here at APS, we have the opportunity to train the students from the west side of Phoenix that are flying with United Aviate Academy, and hundreds of those that are coming to fly with us and have the benefit of doing that early on in their career. It's going to benefit them, through whatever flying paths they choose to go through before they get to a major carrier, because it's all really a lot the same techniques, the aerodynamics and the physics that drive it. But in this particular case, it's United that has the vested interest. They know where the product of their training is going to end up. I've also got a gentleman from Florida Institute of Technology that is here training with us, and we're trying to get the end users, the airlines that are beginning to partner with a lot of training providers to realize that they're going to be the beneficiary, but the right place in training to try and introduce this is at the licensing stage, but then to continue to try to follow up on that as additional type ratings are added. Let's see what we've got here. Freddie Simmons will show his question. It says, what would you think about people who are already online with an airline? Is there anything we can do to improve their training, as well as for people just starting and receiving improved UPRT training? What thoughts do you have there, John?
I think there's definitely things we can do, and we have taken some steps in that direction, and that is to include in the simulator time an upset condition of nose high, nose low, high roll, and that you learn the techniques. But of equal importance is also the aerodynamics of what happens to a large airplane, a high performance airplane, when it gets upset, because you can have the airplane get dynamically unstable, and you need to be aware of that and to be able to recognize how to drive the airplane back to the heart of the envelope. So some of the newer generation simulators with the expanded envelope, they have the ability to teach with pretty high fidelity the characteristics of individual aircraft. And that's a place to start for the people online. Simulation is wonderful, but there is also a great benefit to on-aircraft training. There's nothing like experiencing an upset in an actual aircraft. And I think that where available, on-aircraft training with the right training syllabus, and that's critical, can give you the tools that you need. Because one of the things that we have not dealt with effectively is what happens to humans in high demand situations, task saturation, because the field of view comes down to a very small tunnel. The auditory exclusion, you don't hear very much of anything, and your cognitive processing slows down by about 50%. So in a time of high stress and high demand, your ability to cope with it is significantly impaired. So we need to, where we can, introduce that and make people aware of it and give them simple, easy to remember steps to right the airplane and to drive it toward the heart of the envelope, that even during that time of high stress, they can apply it successfully.
Yeah, and that strategic approach to recovery, that process that you talk about, is something that can be practiced in the simulator. Certainly the model that APS ascribes to, we would like to have certain elements, certain number of people at an operator come and do on-aircraft training, because then they can be the protectors of the human factors, make sure that those types of things are realistically included. IATA, the International Air Transport Association, advocates for having a couple of instructors for a particular fleet type go through on-aircraft training to make sure that they have those type of checks and balances. I'm going to ask you one other question on this subject, John, before we go on to another question that we have from Igor here, which is, can you address the instructor? I know you were an instructor during your airline career, and at that time you had to do unusual attitude training, approach to stall training. Can you talk about the importance of qualifying the instructor to accurately deliver UPRT?
Absolutely. Instructor qualifications are critical, and it's the same philosophy that we use with the complex airplanes, the large airplanes, is an instructor's qualified in one airplane and they know it well and they teach the unique characteristics of that. And the same is true for upset recovery. You need pilots that understand the aerodynamics, they understand the flight characteristics of the airplane, and they understand how to use the tools and capabilities of the airplane to return it to the heart of the envelope and do so without overstressing it and to minimize impact. So it is a very special skill set. And so that as an incoming instructor, you would first, want to learn the specifics of the airplane, but then also a very carefully thought out and demonstrated competency in teaching the loss of control recovery techniques, recognition and recovery techniques, so that you can let the students that you teach have that benefit. When I was an instructor, we actually did aerodynamic stalls in a T-tail jet. And it was very interesting. It was not exactly like the simulator, but those were in days long before extended envelope. But just having that experience gave me the ability to share that with my students in a way that if I hadn't had the experience, they would have not gotten that benefit. So I think the qualification of instructors is very, very important.
All right. I've got, in your presentation, John, you talked about having sort of the political will to address this problem. And Mr. Volovich has this question. He says, Captain Cox, and referring to the problems with the 737 MAX, he says, can we expect either the manufacturers or the regulators to have the primary role in moving the needle on this issue? And if not them, then who leads the charge for reducing loss of control in flight incidence rate? I think that's a very interesting question.
I think the 737 MAX tragedies was a watershed event for our industry. It demonstrated clearly that we have to have a team approach with the manufacturers, the regulators, the operators, the pilots, all have to work together in a cooperative way. And if there is a breakdown in one, it is a breakdown for all. So I think that the regulators are working and recognize that the expectation of safety continues to rise. I think the manufacturers clearly, and I've spoken with 4 of the major manufacturers around the world, and all of them have said that the lessons learned out of the MAX tragedies is one that they took home to their organizations. And so I think that they are willing to be one of the leaders. But I don't think we should, as an industry, turn to a single lead organization. I think that it's important that we recognize each component in the industry brings expertise, brings experience, and brings solutions. And when we mold that together, which is part of what we tried to do with the Royal Aeronautical Society, with ICATI, was to bring industry leaders, experts together in a room and draw from all of them. And I think with the demonstrated complexity of loss of control in flight, that's what it's going to take. It's going to take political will from all of us, from the manufacturers, from the regulators, from the operators, from the individual aviators. All of that together, yes, we can solve it. Without all of those groups, I think we'll be impaired in our effort to reduce the accident rate.
I love that perspective, John, because I think there are different roles that regulatory bodies hold in different parts of the world. And, in many places, it's assumed that if the regulators don't provide a regulation, then it's not important. And I think that, one view is that the regulators just create that minimum regulatory standard, but we have operators and a lot of others that are starting to recognize now that regulatory requirements that are in place are really not sufficient for fully defeating a threat of this magnitude.
I think it's important for one other thing in here too. The industry is moving forward to saying we will do more than the regulatory minimum. We're seeing that with the things like ISBAO, like the Air Charter Safety Foundation, like BASC, like IOSA. We're seeing operators voluntarily comply with a higher set of standards. And in so doing, that may be an opportunity to say, okay, we're going to include a robust upset recovery training program. And finally, the insurers. The cost of accidents right now, and I talked to a couple of the leading insurance companies recently, the cost of accidents to the insurers has skyrocketed. So there is a strong business case for them to encourage operators to take steps in accident prevention. And one of those is upset recovery, prevention, and training.
Absolutely. There are financial motivations for operators and insurers. We have a question here from John Power. Says, what are your opinions of the MPL pilot training programs with reduced aircraft time and increased simulator time in terms of pilot handling competence specific to loss of control in flight incidents once these pilots get on the line with very little actual flight time outside of glass cockpit? Should pilot training have a lot more actual aircraft handling specific to UPRT, unusual attitude recoveries, et cetera, at the ab initio stage? I'll be really interested to hear your perspective, John. I have a few thoughts of my own.
I think the MPL program has proven to be successful, but it's limited in its scope. It is an ab initio program where people come into it with the sole intent of flying a large airliner typically. And so they do get the benefit of that rigidity of the curriculum and the constant demonstration of competencies as they excel and move forward. And as they get into the more advanced training, they do see upset recovery, prevention, and recovery. Would I like to see that expanded? Yes, I would, because I think it's important. But I think that when you're talking about MPL that being implemented, you have to say that a total number of flight hours may not be the best criteria to determine the effectiveness of training or the competency of the individual. I mean, we've seen that as an example in the military. The military takes very low experienced or no experienced people, and over a period of a year and a half, they become highly experienced, competent aviators. We're seeing that being done successfully in a lot of places around the world. So the concept of MPL, I think, is sound, but I think the recognition of the limitations of it and the need for very careful monitoring of the quality of the training and the competency of the individual aviator, those are key. But I think that when we look at solely looking at a total number of hours to say, okay, that is an experienced pilot, I think that goes against what we've seen successfully done in ab initio programs as well as MPL.
I agree, John. And I think one of the things that we have seen is that time spent in the normal envelope does not necessarily translate to proficiency in upset situations. And so there it's a matter not just of the structure, but also of the content of the syllabus. And one of the requirements for MPL, there is a component of upset prevention and recovery training that is required. Unfortunately, as in other places where there are UPRT requirements, what that UPRT training should include is rather undefined. And so it might be very good, it might be comprehensive, or maybe not. We are working at trying to define what good UPRT looks like, so that those that are interested in trying to mitigate the loss of control and flight threat can kind of work at that. So those are all really good thoughts. Now, you and I were talking a little bit before we got started about why we think that, and you used in your presentation the word accepting, and you made it very clear that it's unacceptable to you, it's unacceptable to me, it should be unacceptable to everybody. And yet, other than some of these little aspects that we've been talking about, like we said at the beginning, really hasn't changed since last fall. It's not likely to change anytime soon. Why do you feel like we are more accepting of these fatalities due to loss of control in flight than other areas?
I think there's a couple of pieces to it. One, historically, we have blamed the aviator. Well, that crew did something really stupid, or if it were me, I'd have certainly recovered the airplane. And when you look at a significant number of the upset conditions that resulted in the loss of the airplane, that has been the traditional acceptance, or the traditional answer for it. And we've seen some pretty callous statements made against crews that were fatally injured in the accident type. And I think Dunning-Kruger has something to do with that. I think that bias of people thinking that they're really better than in fact they are comes into play here. Because until you recognize and until you have experienced an upset condition, you really can't appreciate what all is going on with you within the airplane, but also within yourself and your ability to solve it. So I think that has been a sad part of it. I think that when we look at what is acceptable today, I mean, if you go back to the days of Ernie Gann, what the conditions and weather that they flew in with that equipment, most of us wouldn't do that today. What is acceptable in 1940, 1935, we have raised that bar, and yet we've only to a small degree done that with upset recovery. Well, okay, we'll teach unusual attitudes and maybe go out and fly some aerobatics. That's not what we need. We've tried it, and the rate has not gone down. And yet there are people tenaciously that hang on to that of, I don't want to do that in a little airplane. I don't need that. I know how to fly. And that is the Dunning-Kruger effect showing itself time and time again. I mean, I had that conversation probably 2 weeks ago with an individual. So the disbelief that it could happen to you, I think is misplaced. And I think that we find crews, skilled crews, that still end up in places that find it unrecoverable, or that they don't recover. And so I think that we take those lessons, we take the data from the accidents, from the flight data monitoring programs where we see the near misses, and we insert that into a more line-oriented, real-world environment, and so that they have the unexpected events based on what we're seeing in the fleet. And I think that those are the sorts of training tools that we may have that give us an improved recovery rate. Fortunately, we don't see the upsets that often, but the problem is about 50% of the time when we do, we don't see a good outcome. And I think we can lower that percentage of unsuccessful outcomes by making real world training scenarios based on historical facts.
Yeah, it's interesting now that we have that FOQA data, which we didn't have back in the days of Ernest Gann. we can see you're correct that, these accidents and even incidents are relatively rare, but the precursors you can see quite clearly in FOQA data. And for several of the airlines that we work with, it's interesting, they have looked at that data, and a lot of the pilots in training for required upset prevention recovery training at the 121 level kind of have the attitude that we've been talking about of why is this even necessary? And then the airlines are able to share the aggregated data of this is what's going on, where we may be having something that needs to be, requires an intervention, up to once a week or more. And also where these things are occurring are not necessarily down at low altitude. A lot of times they're high altitude slowdowns, things like that. And that really helps to get pilots' attention. The other opportunity that I have here, when we get off of our call today, I'll be jumping in a flight suit to do an evaluation with a major corporate operator to show them the training that we do, because it's a big communication challenge to, you are coming from the point, you talk about stalling a T-tail jet, and I bet that thing was shaken pretty severely, a little bit shakier than a simulator, right? When you went through that. And so those are the kinds of things when I have the opportunity to fly with people, they go, oh, you're helping me with a threat that I didn't even appreciate, that I didn't even know existed, because it's largely invisible in the simulator, whether it's from an aerodynamic standpoint or to the human factor standpoint that you were just addressing, where the pilot's mind is not going to be working in the same way that it is here at 1G while we're having this conversation. Well, we've gotten through about 47 minutes of our hour. I think we've answered most of the things that people have brought up. We're happy to answer any other questions if they are out there. But John, do you have any closing thoughts on this discussion?
Well, I think, it's easy to sit back in an air-conditioned room in a sterile environment and dissect accidents or incidents that have occurred and say, well, okay, they really messed this up. But it can be something as innocuous as distraction. And if the airplane is at high altitude and vertical speed climb mode, and you don't realize that, it is going to bleed airspeed down to the point that you can get stick shaker activation, stall warning activation. And we've seen this in some very complex and high performance airliners. We've seen it not once, not twice, but we've seen it a significant number of times. So for people to say, oh, it can't happen to me, it can. And it can be the result of something as a small malfunction in the airplane that causes a attention distraction. It can be an air traffic control issue, but anything that moves your attention away from monitoring the airplane. Automated airplanes are wonderful, and the time that I spent on the Airbus, that fly-by-wire system, it is absolutely incredible. And I thoroughly enjoyed my time with the airplane, but it did not relieve us as pilots to monitor it and to carefully make sure that the airplane stayed in the heart of the envelope. So I think that we can take some things away, look at the data, see where other crews have had issues. We can learn from those, and then we implement those into training scenarios, carefully crafted training scenarios that drives the lesson home of the recognition, prevention, and then recovery of a potential upset resulting in loss of control. I think we can do it. The question is, do we have the political will?
Well, I want to, I was going to end by adding to that, and Mr. Volovich had pointed to, using data, and I wanted to emphasize a point that you had made, which is that it takes all of us, that I would like to encourage the folks that are listening to look for ways that you can influence people that you work with, because awareness is a big part of this. And you have helped us over the years, John, with several of these types of presentations to call people's attention to it. And our last question perhaps is pertinent down to the individual level. There's Mr. Freddie Simon says, what about me as an individual? What's the number one thing I can do to train myself to improve my personal chances of being prepared for an undesirable attitude situation going forward? And Freddie, that's just exactly the type of question that every pilot should be asking themselves. And the training is available. And so look for folks. You can look online for upset prevention recovery training providers. It's pretty easy to tell the folks that are working beyond just merely aerobatics to teach transferable concepts and that have the instructor competency that John told us earlier was important. But that's the sort of personal responsibility that goes beyond just what the regulators point to. So good luck, Freddie, in trying to find somebody to help you, because just the licensing standards as they are what have resulted in the problem that Captain Cox has been highlighting for us today. Well, John, it's a pleasure. It's been a pleasure talking to you. It always is. I look forward for our next opportunity. Thank you for helping us to speak to everybody today.
Thanks for the invitation, Randy. It's always fun and enjoyable to catch up with you and to have an opportunity like this to talk about one of my favorite subjects.
All right. Well, everybody, we're going to be doing another safety summit here in the fall. This concludes our recaps of last year's summit. But if you look in LinkedIn and other sources where this is being broadcast, YouTube's and others, we'll hopefully look forward to seeing some of you when we talk in the future. So long, everyone.